The modern Tuk Tuk has entered a new era, where the concept of auto-driving or self-driving technology is starting to reshape how we perceive local transport. Traditionally known for their simplicity and human-operated mechanics, Tuk Tuks, or auto rickshaws, have served as a lifeline in crowded cities, narrow streets, and rural pathways across Asia, Africa, and parts of South America. But now, as electric drivetrains and autonomous systems These allow the vehicle to see the road, detect obstacles, make decisions based on real-time traffic conditions, and even park or stop in case of emergency, all without human input. In traffic, stop at red lights, yield when needed, and change lanes with fluidity. What's unique in the case of Tuk Tuks is that they often operate in areas where major aspect of this development is passenger comfort and safety. Unlike traditional tuk-tuks, which have limited structural safety features, the auto-driving models are built with reinforced cabins, cushioned seats, seat belts, and side protection. Some models also include touchscreen panels that allow passengers to select destinations, adjust ventilation, and even play music during the ride. These features are designed to elevate the rickshaw experience from a basic ride to a of these tuk tuks significantly reduces carbon emissions and noise pollution, addressing two major issues caused by traditional autos. With cities pushing for greener solutions and many countries setting deadlines to phase out fossil fuel vehicles, the electric auto drive tuk tuk fits well into global plans for sustainable urban mobility. While the promise of self-driving tuk tuks is exciting, there are still considerable challenges. The unpredictable nature of urban traffic in places like is expected to decrease with mass production and technological advances. In terms of software development, companies are working to fine-tune the vehicle's operating system to handle real-time updates. A tuk-tuk driving autonomously through a market street must adapt if a vendor suddenly moves a cart or if a cow walks into the road, as scenarios common in many countries. These software systems use a combination of LiDAR, light detection and ranging, ultrasonic sensors, and higher resolution. This system could reduce congestion, offer consistent fares, and run 24/7, especially in areas underserved by public transport. Autonomous tuk-tuks could also be used for last-mile delivery, transporting goods from distribution hubs to homes, or even as mobile kiosks, food carts, and micro-mobility units for special use cases. In field tests, we've seen modern auto-drive tuk-tuks successfully complete tasks like navigating through Autonomous tuk-tuks come in various configurations. Some feature enclosed cabins with air conditioning for comfort in hot climates, while others use solar panels on the roof to extend battery life. Bright LED strips indicate braking and turning, while dashboard cameras record each journey for legal and insurance purposes. The compact nature of tuk-tuks makes them ideal for testing auto-drive features in high-density areas where larger cars might struggle. Have to be impersonal, it can be customized and human-friendly. What's particularly fascinating is how these vehicles are teaching engineers about the limitations of urban planning. As auto-drive, the tuk-tuks encounter informal driving patterns such as parked cars in no parking zones or pedestrians crossing highways that they expose captions for editing.